Hello, all my dear students. I welcome you all to Checkview Academy. In today's session, I'm going to discuss a very important concept of your grade 10th current electricity. In these kind of problems, they ask you the reading of the ammeter when there are multiple bulbs connected either in series or parallel. So basically, in these type of questions, you will find multiple ammeters or bulbs connected in either series or parallel, and the question will be find the power consumed by the bulb or how the brightness of the bulb will change when a particular bulb gets fused. Let's start the class. As you can see that the question here is we have three bulbs. All the three bulbs are identical. So we have B1, B1 is here, B2, B3. There are three ammeters also, A1, A2, A3, and fourth one which is A. So A is directly connected to the battery. You can see that. It means the total current, the reading of the total current will be shown by A because it is directly connected to the source. Source is this 4.5 volts. So the first question is, what happens to the glow of the other two bulbs when the bulb 1 gets fused? So when bulb 1 gets fused, what will happen to the brightness of B2 and B3? One thing what you need to understand here is in parallel connection, potential difference doesn't get distributed. So whatever potential this cell is providing or battery is providing, same potential difference will be across these two ends. Same potential difference will be across this terminal and it will be same across this terminal also. So if bulb 1 gets fused, potential difference across B2 and B3 is same as the original potential difference. Potential difference will not change. And what is the formula for the power across bulbs when they are connected in parallel? What formula do we use? We use the formula P equal to V square by R. So since bulb is not changing, means resistance is not changing and the potential difference across them is unchanged if it is parallel connection. So V is not changing, R is not changing. It means the brightness of B2 and B3 will not change if bulb 1 gets fused. They can ask you another question that what will happen to the brightness of B1 and B3 if B2 gets fused? Answer is again same. B1 and B3 are in parallel, so potential difference across them will not change. Therefore, power or brightness of the bulb will not change. So that is the answer for the first part. Now, if you see the second question, what happens to the reading of A1, A2, A3, and A when the bulb 2 gets fused? You need to comment on the reading of A, A3, A2, and A1 if bulb 2 gets fused. So this bulb is getting fused, B2. Now let's understand that what is the total current in the circuit? Total current given in the circuit is 3 amps. You can see that the reading of the ammeter A is given as 3 amps. It means the total current in the circuit is 3 amperes. So let's assume that I am taking the initial scenario where these three bulbs are present and the current passing through them is 3 amps. If three identical bulbs are connected in parallel and let's assume that their resistance is R, what will be the effective resistance? R by 3. So total current will be equal to total voltage by total resistance. So what is the total resistance? R connected in parallel. So it will be R by 3. So since we know that current is 3 ampere, voltage is 4.5 and R by 3. So from here, R by 3 is equal to 4.5 by 3. 3 gets cancelled. What is the resistance of each bulb? Resistance of each bulb is 4.5. Right? I assume resistance of the each bulb is R. Total was R by 3. So I calculated R as 4.5. Perfectly fine. Now, once you know the resistance of each bulb is 4.5, now in the second case, what they're telling that was one of the bulb is fused. So B2 is fused. Now you have only two bulbs, B1 and B3. So what will be the net resistance now? R by 2. Correct? R by 2 because this bulb is over. 1. Game over. It is removed from here. So when this bulb gets fused, it means this is broken circuit. There will be no current in this. So you can ignore this branch. So this branch is over. You can ignore it. Now, B1 and B3 are present. So what will be the R equivalent now? R by 2, right? Now, what is the value of R? R is 4.5. So you need to find what is the reading. So what is the meaning of reading? Reading means how much current is flowing. Current is basically potential divided by total resistance. So suppose I want to find the reading of this. So what will I write? I will write I equal to V by R. So what is R here? R by 2. So V is same as this battery ka potential, 4.5 divided by R by. R is how much? 4.5. So 4.5 divided by. So what will be current? 2 into 4.5 divided by 4.5. So our total current is 2 amps. So in the second case, when one of the bulb, which is bulb 2, is fused, total current flowing in the circuit is 2 amps. And this ammeter is directly connected to the battery. It means this will show you the total current. The total current is, now this current will move from here. This current will move from here. 2 amps will move from here. Some current will go into this. Some current will go into this one. And the current in this branch will be zero because this circuit is broken. This bulb is fused. So since bulb 3 and bulb 1 are identical, whatever is the total current will get distributed into two equal parts. So 2 ampere ka half will be 1 and 1. So final answer, A1 will be half of 2, which is 1 ampere. Reading of A2 will be 0 because the bulb is fused, circuit is broken. A3 will be same as A1 because 2 is divided into 2 equal halves. So this will be 1 ampere. And this will show you the total current in the second case. So what is the total current? 2 ampere. So reading of A will be perfectly fine. One of the best and conceptual question of your current electricity, which teaches you R equivalent, what is a parallel series connection, how the current gets distributed. In one question, multiple concept is involved. So that is the reason I took this question so that all your fundas get clear. Now, the last part of this question, how much power is dissipated in this circuit when all the three bulbs glow together? So for power dissipated in the circuit, we will use I square R. So this time they are telling that all the three bulbs are working fine. So when all the three bulbs are working fine, what was the total current given in the circuit? 3 ampere. So current will be 3. So 3 square. And what was the total resistance? R by 3. Correct? R by 3. So what is R? 4.5. Why R by 3? Because all three identical connected in parallel. R by 3. R by 3 means 4.5 by 3. So 4.5 by 3. So this becomes what? 3 square, 9. And this is what? 1.5. 15 nines are 135. So what will be the answer? 13.5 watts. 13.5 watts. So very nice problem. All three parts were discussed. Let's take the next question. Okay, students, let's discuss the next question. If you see that in this question, we have three bulbs, each of 100 watts, which are connected in series. And we have another set of three bulbs of the same wattage, means 100. But this time connected in parallel, but with the same source. Battery is same. So will the bulb in the two circuits glow with the same brightness? So they are telling that the brightness will be same in series or parallel or not. Let's discuss it. Let's draw the circuit first. We have three bulbs, bulb 1, bulb 2 and bulb 3. So B1, B2 and B3. All three are identical bulb, 100 watt and connected to a cell or battery. Now same, this time we have these three same bulbs, but this time they are connected in parallel. So B1, B2, B3 and same source. Same source. Correct? Series circuit, parallel circuit. Now, you need to tell that will the bulb in the two circuits glow with same brightness? Justify your answer. Justify your answer. So here they are identical bulbs. Let us assume that their resistance is R. Let us assume that the resistance of each bulb is R. So what will be R equivalent in this case? 3R. Right? And what will be the equivalent resistance in this case? Because they are connected in parallel, R equivalent will be R by 3. So since here the resistance of the circuit is 3R and here it is R by 3, you can see resistance is very high, not high, very high as compared to this parallel circuit. So since resistance is high, what will happen here? The current will be less, right? Current flowing through each bulb will be less as compared to the parallel connection because resistance is higher as compared to parallel. So resistance is higher means current will be less. So in series, current will be less. Hence, the brightness of the bulb will be also less in series as compared to. So very fundamental and conceptual, you can say question or topic. But the moment you apply your fundamentals and basics, easily you can answer. So our answer will be for parallel, brightness will be more. So answer is parallel. Now what they're telling that now let one bulb in both the circuit gets fused. Will the rest of bulbs continue to glow in each circuit? Let's understand that. So in series, let's assume that B2 fuse. So the moment one of the component fuses in series circuit, the circuit will be broken. The circuit will be open circuit, and in a open circuit, current doesn't flow. So in series, if any bulb fuses, circuit will be open, and there will be no current in the circuit. Okay, but here what will happen? Any bulb fuses. Suppose B1 fuses. So what will happen? Still B2 and B3 will have some current flowing into them, will have some potential difference across them. So B2 and B3 will perfectly glow. Or you can say B2 fuses, then B1 and B3 will glow. And that is the advantage of parallel connection over series. That if one of the components stop working, the other component connected in the parallel circuit will be unaffected. And that is the reason in our household circuit, parallel combination is used. This is the one of the most important reasons. Correct? So what will be the answer? In parallel connection, the rest of the bulbs will glow. But in series, the moment one of the components stops working, the whole circuit stops working. So let's take one last question of this power consumed or how the current distribution happens. Okay, students, let's take the last question. As you can see in this question, we have a current of 1 ampere which flows in a series circuit which contains a lamp and a conductor of 5 connected to a battery of 10 volts. Calculate the resistance of the electric lamp. Now they are telling that we are doing a small change in the circuit. Now, if a resistance of 10 ohm is connected in parallel with this circuit, means given circuit, what change in the current through the 5 ohm and potential difference across the lamp will take place? Give reason. Let me draw the circuit quickly. So our initial circuit is we have a lamp and a conductor. So let's take a bulb instead of a lamp, and we have a conductor whose resistance is 5 and connected to a battery of 10. I don't know the resistance of this R, and this is 5 ohm. This is 10. So this is our initial circuit. Correct. Now, final, or you can say the second scenario. In the second scenario, we have an extra resistor of 10 ohm connected in parallel. We have one more resistance of 10 ohm in parallel with this, and then we have a battery. This is 5, this is 10, right? And this is 10 volts. So what is the first part? Calculate the resistance of this. Very simple, right? Very simple, because total current is given. So what's the total current? 1 amp. So how will you find this R? Total current is equal to total voltage divided by total resistance. So what is the total resistance of this circuit? These two are connected in series. R plus 5. So it will be 10 divided by R plus 5. And we know that current is 1. This current is 1. So cross multiply. R plus 5 equals to 10. So from here you can find R as 5 ohms. So the resistance of this lamp is also 5 ohms. Now we connected a 10 ohm ka resistor. So here we have 5. We found this 5 and 5, which is 10. 10 is connected in parallel with 10. So what is 10 and 10 ka parallel combination? 5, which is 10 by 2. So if I simplify this circuit, this simplified circuit will be 10 and 10 ka parallel combination, which is 5 connected in combination, series combination with this battery. If I draw the simplified circuit, I can say that let us draw the circuit here. This will be 5 and 5, 10, 10 and 10, 5. Correct? So this will be 5, which is connected with a battery of 10. What is the current in this? So current in this will be 10 divided by 5, which is 2. So in the second circuit, the total current is in this total current. Now, how the current will get distributed? So the total current is 2. Current will reach to this point. The moment current reaches to this point, current says that I have two ways to move. One path in this 10 ohm and other path this 10 ohm. But both have 10 and 10, means you have two identical paths. It means the current will get distributed into two equal parts. So 2 comes here, 1 goes into this, 1 goes into this. So the moment 1 goes into this lamp and this, I want you to now find out what will be the potential difference and current passing through this. I already told the current. Find the potential difference and compare with the initial circuit, and do write down the answer in the comment box. Is the potential and current changing, or it is same as the initial scenario? So I hope that you guys learned a lot of new concepts in this session. Do share it with your classmates and friends, and keep working hard for your board exam. And I will be bringing some more and conceptual videos on your physics and maths. See you guys in the next video.